This lesson reviews two types of sequences that we've already studied and introduces a new type of sequence. So the first type of sequence we looked at was called an arithmetic sequence, and hopefully you remember what that means. That means you start at a certain number and then you keep adding or subtracting the same amount. So we represent that in symbols like this. U sub 1 is I. I'm using I here to stand for your initial or starting value. And then in general, to get a certain term, let's call it the nth term, you look at the term right before it, which we'll call u sub n minus 1, and you add the common difference. Remember, if the common difference is negative, then the terms will be getting smaller and smaller. It's like you're subtracting the same amount each time. We also looked at geometric sequences. These are ones that, similarly, you start at a certain number, and then what you do is you just keep multiplying by the same ratio. So I guess I should put a little dot in there for multiply. Okay, so again, you start at some initial value and you repeatedly multiply by a common ratio to get subsequent terms. All right, the new type of sequence is called a shifted geometric sequence. Again, I'm missing a 1 here. We start at some initial value. There should be a 1 right here. So I'll call the first term I, and then to get any term, what you do is you multiply the previous term by the common ratio, and then you add some amount, which I'm calling the shift. Okay, so let's look at an example. So this is a shifted geometric sequence, and the starting value is given as 20. So what I'm going to do is find the first several terms of this sequence. Okay, well, u sub 1, I'm told, is 20. Now, to find u sub 2, I need to do 0.2 times 20 plus 3, which I worked out, and that comes out to be 7. Okay, so then to get the next term, u sub 3, you would take 0.2 times what we got above, 7, and add 3 to that. And again, let me check my list. That came out to 4.4. Okay, and then we would just keep repeating that process. To find the fourth term, we'd multiply 0.2 by this result, 4.4, and add 3. And if you do that, you would get 3.88. 3.88. And then the next one after I did the calculations was 3.776. And then after that I got 3.7552. And you can keep going. Now, you may notice that these numbers seem to be getting closer and closer to 3.75. And in fact, when you use an L to stand for limit, the limit of this sequence is said to be 3.75. That means that's what this sequence is closing in on. It's kind of like the attractor value that we looked at earlier. All right, so there's an algebraic way of actually finding that 3.75, and it's kind of interesting. So here's what you do. You take this u sub n equals 0.2 times u sub n minus 1 plus 3. And if there is some limit or attractor value, once you reach it, you'll keep getting that number over and over and over again. So let's just assume that at some point you reach that limit. That means that when you plug that limit into the rule, what you get will be equal to what you started with. So if you do 0.2 times L plus 3, it should give you back that limit of L. Now we just solve this equation. If I subtract 2L from each side, I'm going to get 0.8L equals 3. And so L, I would have to divide 3 by 0.8. You can check that on your calculators. Comes out to be 3.75. Okay, that shows algebraically that the sequence defined up here has a limit of 3.75. The terms are getting closer and closer and closer to 3.75. 27, 4.4, 3.88, 3.776, 3.7552. The limit is 3.75. Okay, that's kind of sophisticated. I think that's a neat trick that you can figure that out with algebra. Alright, so here's your homework assignment. I've defined a shifted geometric sequence here by telling you the first term is 80, and then I'm telling you to find the next term. You multiply by 0.75 and add 10. So do that and get 15 terms, and then use the algebra process shown in the previous screen to find the limit. Okay, pause the video if you need to copy that down.